Imagine an ordinary California morning. Blue sky, coffee brewing, traffic humming on the 405. Then, without warning, the ground murmurs just a shiver at first. Glasses tick, a picture frame tilts. In the next heartbeat, the murmurs become a roar. Floors heave, streetlights sway. Car alarms scream in chorus with a sound like a freight train tunneling through the earth. This isn't a movie trailer. It's the opening seconds of what scientists call the Big One, a massive earthquake along the San Andreas Fault that isn't a matter of if, but when. Not a myth, not an internet rumor. An event baked into the geology under California's feet. Over the next minutes, we're going to strip away the headlines and the hype. We'll see why California is earthquake country, how the San Andreas really works, and what history's worst quakes have already taught us. We'll walk through the most credible Big One scenarios. What could fall, what could burn, what might stop moving, and for how long. And we'll talk about the aftermath, how cities bend or break, how people adapt, and which choices, made today, decide tomorrow's story. Because the ground will move again. The question isn't whether California is strong enough. It's whether we're prepared enough. Take a breath. Look around the room you're in. If you had 10 seconds of warning, what would you do? To understand the Big One, we need to start beneath our feet. The Earth's crust isn't one solid shell. Instead, it's broken into gigantic puzzle pieces called tectonic plates. These plates float on a sea of molten rock, and they're constantly moving, slowly, silently, reshaping continents over millions of years. California happens to sit on the border of two of the most powerful of these plates, the Pacific Plate and the North American Plate. Imagine two massive slabs of rock, each hundreds of kilometers thick and thousands of kilometers wide, locked in a never-ending shoving match. The Pacific Plate is sliding northwest, while the North American Plate pushes southeast. Their boundary runs like a scar across California, the famous San Andreas Fault. This fault line stretches more than 1,200 kilometers from the deserts near Mexico to the northern coast by San Francisco Bay. Along that length, the Earth doesn't move smoothly. Sometimes the plates slip little by little, too small for humans to feel. Other times, they jam together, storing incredible amounts of energy for decades or even centuries. When that built-up stress finally snaps loose, the plates lurch past each other, releasing energy equal to dozens or even hundreds of nuclear bombs. The ground shakes, the surface cracks, and human structures, no matter how advanced, suddenly feel fragile. California is rocked by thousands of small earthquakes every year. Most are harmless, hardly noticed. But history reminds us that small quakes are simply whispers. They're the Earth adjusting, flexing, warning. Because sooner or later, the San Andreas will unleash something far bigger. Living in California means living with this reality. The same forces that created its stunning mountains, valleys, and coastline also guarantee powerful earthquakes. That tension between beauty and danger, creation and destruction, has always been written into the land. This is why scientists speak of the Big One with certainty. The plates are still moving. The stress is still building. And somewhere, hidden deep beneath the surface, the countdown is quietly ticking. When people imagine the San Andreas Fault, they often picture a single deep crack running across California. But in truth, it's not just one line. It's a system of fractures, a tangled network of breaks in the Earth's crust stretching for more than 1,000 kilometers. Each section behaves differently, and those differences matter. Some parts of the fault are called creeping segments. Here, the plates slide gradually against each other, almost continuously. These slow slips don't release large amounts of energy at once, so they rarely produce catastrophic quakes. It's as if the Earth is quietly adjusting itself, shifting millimeter by millimeter. Other sections, however, are locked. They don't move at all. For decades, sometimes centuries, the plates remain stuck like two wrestlers frozen in a deadlock. But the forces pushing on them never stop. Stress builds, energy piles up, until finally, the rocks snap loose and shift violently. In seconds, centuries of strain are released in an earthquake that can last minutes, and be felled across entire states. The southern portion of the San Andreas, running close to Los Angeles, is one of these locked sections. Scientists know it hasn't ruptured in more than 300 years. That's far beyond the average cycle between large quakes. In other words, it's overdue. When this locked segment finally breaks, models show it could set off a rupture more than 300 kilometers long. The shaking would ripple outward, weakening buildings, twisting highways, and overwhelming emergency systems. The energy would radiate not just through California, but across much of the western United States. It's important to realize the San Andreas doesn't generate earthquakes evenly. Some years, Californians feel only minor tremors, but the quiet years are misleading. They aren't proof of safety. They're proof of accumulating tension. The San Andreas Fault is not a sleeping monster. It's a restless one, and every day that passes without a major quake means the eventual one grows stronger. To understand the danger of the San Andreas, we don't have to look to imagination. History has already shown us what happens when it breaks. The first major reminder came in 1857 when the Fort Tejon earthquake struck Southern California. Scientists estimate its magnitude at 7.9, powerful enough to rank among the strongest in U.S. history. For nearly 350 kilometers, the ground ruptured. In some places, the land shifted sideways by more than 9 meters, an entire two-lane road's width. Ranchers watched fences twist out of alignment, rivers change course, and the earth itself tear apart in seconds. Fortunately, the region was sparsely populated at the time. Few lives were lost, but the scale of destruction made it clear. The San Andreas was capable of reshaping the land. Just under 50 years later, disaster returned, this time in a city. In 1906, San Francisco was rocked awake by another estimated magnitude 7.9 earthquake. Wooden houses collapsed instantly. Gas mains ruptured, sparking fires that raged uncontrolled for 3 days. By the end, roughly 3,000 people were dead and 80% of the city lay in ruins. Entire neighborhoods vanished, swallowed by fire and rubble. The quake didn't just destroy buildings, it destroyed confidence. San Francisco, once booming, was forced to rebuild itself almost from the ground up. Since then, California has felt many smaller but still sobering shocks. In 1989, the Loma Prieta earthquake struck near Santa Cruz, collapsing parts of the Bay Bridge and halting the World Series in San Francisco. In 1994, the Northridge earthquake hit Los Angeles, toppling freeways, killing dozens, and injuring thousands. Each of these events carried its own lessons. Engineers learned how buildings failed. Lawmakers rewrote safety codes. Emergency responders improved their plans. But each quake also carried the same chilling reminder. No matter how much progress we make, the San Andreas still holds the power to deliver something far worse. The Fort Tejon quake, the 1906 San Francisco disaster, Northridge, Loma Prieta. These are not just stories from the past. They are warnings written into the ground, reminders that the big one has happened before and will happen again. So what will the big one look like when it finally strikes? Scientists have run detailed computer models to answer this question, and the results are sobering. One scenario begins on the southern San Andreas Fault near the Salton Sea. There, the locked segment finally ruptures. The break races northwest toward Los Angeles at almost 3 kilometers per second. For over 300 kilometers, the fault rips open, releasing centuries of pent-up energy. The shaking in some areas lasts nearly 2 full minutes. That may not sound long, but imagine everything around you shuddering, buckling, and collapsing for 120 endless seconds. In this model, freeways buckle and bridges topple, isolating neighborhoods. Power lines snap, leaving millions without electricity. Water mains burst, cutting off clean water supplies. Gas pipelines fracture, igniting hundreds of fires across the Los Angeles basin. Emergency responders struggle to move through a city where roads are blocked, communications are down, and panic spreads faster than the flames. Another scenario explores the economic fallout. The ports of Los Angeles and Long Beach, together handling about 40% of U.S. imports, are shut down for weeks, maybe months. Ships wait offshore, unable to unload. Warehouses sit empty. Supply chains snap. What begins as a local disaster quickly ripples across the country, then across the world. Some scientists warn that the big one may not come alone. Powerful quakes can trigger aftershocks, sometimes nearly as destructive as the main event. Landslides could sweep through mountain communities. Liquefaction, where solid ground turns to quicksand, could swallow whole neighborhoods built on soft soil. All told, the damage could reach into the hundreds of billions of dollars. Tens of thousands of homes could be uninhabitable. Millions of people could be displaced. And while California has invested heavily in safety codes and retrofitting, no system is foolproof when facing the raw power of geology. These scenarios are not predictions of exact outcomes, but they are warnings, carefully calculated, scientifically modeled possibilities that show how quickly modern life could unravel when the big one finally arrives. If the big one struck tomorrow, California would wake up to a different world. Entire neighborhoods could be reduced to rubble. Skyscrapers built before modern safety codes might lean or collapse. Highways could remain impassable for weeks, cutting Los Angeles off from surrounding regions. In rural areas, small towns might find themselves stranded without outside help. But the most profound changes wouldn't just be physical. They would be social and psychological. Imagine millions of people without power, clean water, or reliable communication. Imagine shelters overwhelmed, hospitals stretched beyond capacity, and families separated in the chaos. For a state of nearly 40 million people, even the best emergency plans will be tested to their limits. Economically, the impact could redefine California's role in the world. Silicon Valley's technology companies might be unable to operate. Hollywood studios could grind to a halt. Agriculture in the Central Valley could suffer from damaged irrigation systems. California's GDP, the fifth largest economy in the world, could shrink dramatically in the span of weeks. The effects would ripple across the United States and far beyond. Yet history suggests something else as well: resilience. After every major quake, Californians have rebuilt. San Francisco rose from the ashes of 1906. Los Angeles re-engineered its freeways after Northridge. With every disaster, engineers strengthen designs, lawmakers enforce stricter codes, and scientists refine early warning systems. Today, new tools add to that resilience. Earthquake early warning apps can deliver precious seconds of notice, just enough to duck under a desk or shut down a train. Communities run drills, preparing children in schools and workers in offices to respond calmly instead of with panic. Families are encouraged to keep emergency kits, food, water, flashlights, radios, first aid. Will these measures prevent all damage? Of course not, but they will save lives, reduce suffering, and help California recover more quickly. The big one will mark a turning point, but it won't necessarily mean collapse. It could instead be a test that reshaped California into something stronger, safer, and more prepared for the next century of quakes. The San Andreas Fault is more than a line on a map. It's a reminder that the ground beneath us is alive, restless, shifting, and unpredictable. For Californians, that reality has shaped daily life for generations. Earthquake drills in schools, emergency kits in garages, quiet reminders that one day, the tremor underfoot won't just be another small shake. When the big one comes, it will not ask permission. It will not arrive on our schedule. It will tear through cities, towns, and highways on its own terms. The only choice we have is whether we prepare for it or ignore the warnings written by history and science. Yet amid the danger lies a truth worth remembering. Humanity has always endured the forces of nature. Civilizations have faced volcanoes, tsunamis, hurricanes, and floods. Each time, survival came not from fear, but from preparation, cooperation, and resilience. California's story will be no different. Yes, the big one will come. Yes, it will bring destruction and hardship. But it will also bring out the ingenuity of engineers, the courage of first responders, and the determination of communities to rebuild. So when we speak of the big one, we're not just speaking of a disaster. We're speaking of a test of how well science can warn us, how well we prepare, and how well we stand together when the Earth decides to remind us who is really in charge.